Hello learners, welcome to the topic Civil Engineering Theoretical Design to Field Design with Industrial Building Case Studies. So this slides mainly shows what are the left side, what are the subjects you are learning and what are the discipline wise we are categorized when we go into the organization or industry. So coming to the theoretical design into field design, I just captured the main differences what you have learned from the college when you go to the organization, what you have to mainly take care. See on the left hand side, you will be studying the analysis of structures. In the analysis of the structures, all your input should be on the point load, uniformly distributed load, restraint and the support condition. See for example, if you consider a beam of span of 3 to 4 meter, when it is subjected to a point load of 2 ton, you will be doing the analysis using your moment distribution method or manual method, and you will arrive the moment and shear force and the deflection. So this is the way you will be doing in your college. When you come to a field design, what we have to mainly take care is we have to understand the geometry of the structure. We have to see what is the design basis report. The main point is design basis report. We will capture the following details in the design basis report. We will understand the geometry of the structure, the function of the building and the type of the building based on the requirements from the client. We will calculate the loads, design loads, which we will be taking referring some codes. So these are the codes IS 875 part 1 to part 5. Please students keep note of these codes because these codes is not available in the college which you are studying. So these are the very basic codes which you have to learn from your own before you come into the industry. So these design loads we are referring the dead loads. What are the dead loads? Dead loads is the sulfate of the structure. If it is a RCC structure, it's like a sulfate of the concrete, sulfate of the finishes. If it is steel structure, it will be the sulfate of the sheeting, purlin, runner, everything. So all these unit weights which is dealt in this particular dead loads which you have to refer in IS 875 part 1 1987. This is how many columns will come based on the grid reference. We will be giving the numeration and what will be the LS. This is the longitudinal section. This section is very much required to plan the shuttering at site. Without this drawing they can't do because where the tie beam is coming, where the RC bracket is coming, where the beam at roof level is coming, where and all office. These two areas are office I explained. So these based on this drawing they will plan for the shuttering. And you can see the relevant pictures also I have captured from my site. This is the column with two RC bracket and we have the filler wall of block wall. And this is the mullion drawing because this block wall we cannot rest it as in the we need to have the mullion to support the block wall because block wall cannot support above 3 meter or like in a span of some 6 meters. So we need to have the mullion to support this block wall. So these are the mullions you can see in this slide. So next is on the beam and slab. So we have the office area on either side of the manufacturing shop. You can see the north and south side we have this much office area. So this office area we have the floor beam and the floor beam slab. So in this also we will be capturing, this is the numeration drawing of the floor beam. So clockwise. See you can see the one side of the office, it's a mirror on the other side, but we need to have the entire beam. This is the span of the beam, this is the beam ID and how it looks. The cross section also we need to see this is the beam, this is the slab and what is the beam ID. This entire right side is we have given the beam ID. This is the numeration drawing of the beam.